America's defense is on land, on sea, and in the air. But its greatest threat is from space. The intercontinental ballistic missile, traveling above the atmosphere at speeds of almost 5 miles per second, destined for a target within our borders. The danger is great, but we need not be helpless against it. Its approach can be detected and tracked. A killer missile is being developed to intercept and destroy it far from its intended target. For this killer missile, the U.S. Army looks to its Nike Zeus. Recent history attests to the age-old military principle that for every new offensive weapon, there can be a defense. In June 1944, the V-1, launched toward targets in Holland and England, was a frightening development in the war. A flying bomb carrying 1,000 pounds of explosive capable of vast destruction. It was a trump card held by the Germans, and it was played in earnest. Then Allied fighters and anti-aircraft batteries began to play a trump card of their own. Guiding the 90mm guns was the Army's new electronic fire control system. Based on new principles, it provided target data for the guns electronically, rapidly computing wind, velocity of the V-1, and many other factors. Computers did the brain work. With experience, the score of hits began to rise. What for a while appeared to be an overwhelming threat was in this case almost entirely nullified. This very weapon system was based on principles that in our time have led to the development of America's first anti-aircraft guided missiles, the Nike family. Ajax for defense against conventional types of aircraft. Then, to meet freighter demands against supersonic jet aircraft, Nike Hercules. And now, in the space age, the Army's answer to the threat of the ICBM, Nike Zeus, upon which so much of our future security may depend, whose potential capabilities challenge the imagination, and which would not be possible without the high plateaus of knowledge and experience reached in developing its forerunners. Technical direction for this program was assigned by Army Ordnance Missile Command to the Army Rocket and Guided Missile Agency at Redstone Arsenal, Alabama. For the basic system concept in the Nike program, the Army turned to Bell Laboratories, where achievement has come through continuity of effort and an attitude of vigorous inquiry. Here it is traditional to discover possibilities where none seem to exist, probing off the beaten track, finding an answer in the darkness. This is the routine that has created Nike. Time to think and to try. Lead time. You cannot suddenly buy the long period of research that must precede final production. Nike Zeus is evolving out of experience over the past 15 years. Its story begins in 1945 when Army Ordnance asked the team of Western Electric, Bell Laboratories, and Douglas Aircraft to explore the possibilities of an anti-aircraft defense weapon capable of attacking high-speed, highly maneuverable bombers. In designing the Ajax system, a principle was employed which was to greatly affect the design of Hercules and Zeus. All three missile systems have their electronic brains on the ground rather than in the missile. After a missile is fired, the expensive machinery of guidance remains intact, ready to be utilized for subsequent firings. Early in 1952, Ajax, armed for the first time with a warhead, was fired. An extremely complex problem in applied physics was put to the test and solved. The same team was called upon to produce Hercules to have a range 3 times greater than Ajax and the ability to carry a nuclear warhead. Now radar had to be more powerful for the longer range of the missile. In a sense, our scientists were beginning to stretch muscles that were to be needed for Nike Zeus. The Army Rocket and Guided Missile Agency had asked for a missile of greater speed, range, and explosive punch. Hercules was the answer. This system has intercepted targets traveling faster than 2,000 miles an hour, and balloon targets at altitudes of more than 150,000 feet. Today, Hercules and Ajax are proven weapons guarding our cities, homes, and factories. America's steady growth of experience in the command guidance systems developed for these missiles has been essential in preparing us for a new challenge, an anti-missile system for the space age. Here is the concept of Nike Zeus. Much of it is now a reality. The Army industry team developing Zeus is driving toward its complete realization. Far outside the atmosphere, radar beams endlessly sweeping the skies detect the oncoming missile. Information flashes to a defense center and then to a precision radar assigned to track the target. When the enemy warhead is within range, Zeus is automatically fired. The booster drops away. A missile track radar guides Nike Zeus toward its target. The sustainer motor is released. The final stage with its deadly warhead can be steered by a vectoring motor. When Zeus reaches the target, it will be detonated, far enough away from the defended area to save it from damage. As missile technology advances, a warhead hidden in a cluster of decoys to confuse our radars becomes possible. For this eventuality, high-precision ground equipment is being developed which will discriminate between decoys and real targets. The system is being designed to fire missiles against multiple targets. The Zeus development project is a countrywide effort under the Army Rocket and Guided Missile Agency. Bell Telephone Laboratories, with the Western Electric Company and the Douglas Aircraft Company, is directing the efforts of 17 major subcontractors, 81 other subcontractors, and hundreds of small businesses. Early in the development program, an engineering concept review brought together the many agencies concerned with training, logistics, development, and production, bringing to bear years of experience, assuring that Nike Zeus would be combat ready at the earliest possible date. Zeus is now far more than a theory. Today, in its research and development stage, the facilities and production methods of American industry are being actively employed. Western Electric is the prime contractor. In its North Carolina plants, it is fabricating intricate computers and many other electronic system elements. The target intercept computer is the responsibility of Remington Rand Univac. As an example of participation, several major contractors are working on the target track radar. The antenna mount here is being assembled at Coffeyville, Kansas by Continental Can. The large weldments by Alice Chalmers in Milwaukee. The Vickers Company in Detroit is producing the hydraulic drives. And Normco in La Mesa, California is designing and fabricating the reflector assemblies. The combined efforts of these many companies is directed toward completing a full-scale Zeus test installation at White Sands Missile Range. Here, terrain, facilities, and personnel have already made possible the thorough evaluation of the two other members of the Nike family. Site construction is under the Corps of Engineers. Burns and Rowe of New York City are the architect engineers. For the missile track radars to be installed here, the Steel Products Engineering Company is fabricating antenna mounts. Goodyear Aircraft has developed and constructed the acquisition radar antennas for the transmitter as well as the receiver. Continental Electronics of Dallas is designing the transmitter for tactical use. This transmitter generates the high-powered pulses which are reflected by objects in space to the receiving antenna. This early design stands some 8 stories high. The lens under this radome is composed of polystyrene foam blocks. These blocks have been developed and produced by Dow Chemical and Armstrong Cork, as well as Goodyear. The antenna utilizes the Lüneburg lens principle to acquire signals from smaller objects and cover wider areas than previously possible. For the target track radar, the Sperry Gyroscope Company is developing the high-power transmitter and, under a Signal Corps contract, the Klystron 2. While work proceeds on the ground-based electronic system, a missile test firing program is already underway. A booster being developed by Thiokol arrives from Huntsville, Alabama for a scheduled firing. In another bay, the final stage, which will include a stable platform by Lear Incorporated, is checked. The Sustainer motor by Grand Central Rocket Company will carry this final thrust vectoring stage to the outer limits of the Earth's atmosphere. The booster generates almost 500,000 pounds of thrust, the greatest single solid propellant motor yet developed in the free world. Sustainer and final stage checked out of the assembly area are on their way to the launch site. The test day has arrived. The tests about to be performed on this early configuration will answer numerous questions on aerodynamic characteristics of the missile. On the ability of the missile to withstand the intense heat generated by the extreme speed of Zeus. And on underground launching equipment. For development tests of the missile to extreme ranges, Nike Zeus will be fired out over the Pacific Ocean from this launcher site. Extra atmospheric tests of the thrust vectoring final stage will also be conducted here. Studies and tests of the Zeus system will be carried out over increasingly longer distances. On the Atlantic range, ballistic missiles fired from Cape Canaveral will provide an opportunity to test the target track radar and discrimination equipment installed on Ascension Island. At Kwajalein Atoll in the Central Pacific, construction for an entire Zeus test system is well underway. This system will be tested against Atlas ICBMs fired from Vandenberg Air Force Base in California. Integrating Nike Zeus with other elements in the defense complex is part of our defense planning, which ensures the one-step-ahead concept. Again, Zeus is our country's only anti-missile system under development today. Being made a reality. Moving ever forward in development to meet the challenge.